Great. So AWS and Databricks are partners. And today, what we're hoping to do is discuss a little bit or share some knowledge about how to leverage the security services that both of us have to protect any of the workloads that you're running on AWS, including your Databricks workloads. And to kick it off, we wanted to start with talking or discussing some public sector trends and challenges that we've seen as public sector solution architects.
So some of the challenges that we've seen in the field working with public sector companies are, first off, the ability to, the need to modernize from legacy systems. And this is especially important given the pandemic that we've all gone through. It's heightened the need to allow collaboration between a remote workforce. Secondly, we have a need for cybersecurity. Now, this has always been a priority, but it's especially important for our public sector folks, and also given the recent high security breaches recently. And then next, we have the predictive maintenance. So when we think about predictive maintenance, that pertains to our subways, our trains, shuttles, buses. So really looking to understand how we can predict when we'll need to repair a machine. It could also be a medical device, right? So we want to save revenue for the government, but also ensure that we can predict when that maintenance will be needed. And then fraud. Fraud, everyone is aware of the risk with that. It's widespread. It costs the government billions every year. But we want to make sure that we are addressing fraud when we think about tax, healthcare, social security benefits. How can we address that today? And then finally, we're going to talk about enhanced citizen services. So the ability to provide those services to citizens quickly for state and federal benefits, but make it easier for our citizens to access and discover the services that are most applicable or relevant to them. So how do we get there? The first thing we're going to want to do is use AI and machine learning to eliminate dependency on outdated technology for data-driven missions. So going from that journey from on-premise to cloud, we want to eliminate that dependency, but not limit our ability to meet that mission. Second, we want to leverage artificial intelligence to actually identify anomalies in the access that you're receiving in your traffic. And that's going to allow us to mitigate any threats to our sensitive data. And then third, we want to use data insight to reduce downtime for those machines. So ultimately, being able to look and predict those costly repairs before they arise. And then with fraud, in order to actually identify and prevent fraud, we need to be able to see real-time streaming and data coming in. So again, kind of modernizing those applications to support receiving those data and insights in real time, so we can, not just identify, even predict, but immediately mitigate once we see that come in. And then finally, we want to use our digital data and machine learning to personalize the experience for our citizens so we can provide those services to them. So a lot of times we hear they don't know these services are available to them. If we can personalize and actually recommend services for our citizens, they can have a more streamlined access to that, and we can centralize that. So why, we know what we need and how to get there, but why are we still struggling with data and AI? First off, what we've seen is there is fragmented view of our data. So we're unable to access that data and merge it across different agencies or business units. It exists in silos. And there's very limited support for that unstructured data and streaming capabilities. Second, the amount of data that we're ingesting now, along with the velocity, is outpacing our legacy technology that we've grown dependent on. So we need a way to be able to scale and simplify those data architectures and workflows. We're also going to need batch processing, streaming processing. So there's a lack of real-time capabilities, mostly due to that legacy on-premise going from a standard legacy architecture. So we're going to batch processing, and those disjointed analytics tools are no longer enough to kind of get us to where we're able to prevent any kind of fraud, and we need the ability to get real-time insights and responses. And then finally, as we look at that data maturity curve, historically we've been able to answer what happened, what are our operational, what are our trends, but what we really need to do is to be able to get to that right side of the maturity curve where we can go and say what will happen, when should we be staffing and going in and scheduling repairs. So moving from measuring to actually anticipating and proactively engaging. So now we're going to look at some modern data architectures that will help us with this.
Awesome, thank you. So here is an example of a modern lakehouse built on AWS Cloud with Databricks. The AWS services shown on screen, those are serverless. So that just means that you don't have to manage those underlying servers, right? And it allows you to continue business as usual, regardless, or rather giving you minimal impact on both the environments and so on. So if you do have sustainability goals, serverless architecture is one way to help you support that or achieve that goal. So let's review it from your case, left to right, this way, right? So I'm going to start with the section that kind of says streaming data. Now, what I would highlight here is continuous and scheduled ingestion is supported. And that means it allows for the receipt of real-time data from your IoT devices, from your message queues, from your web services, all that such. That's going to be supported in a continuous flow for that real-time data. Now, for batch processing jobs, we deliver that data or those files or those data stores to your cloud storage, and ultimately that's used to hydrate. We'll use that term to mean like ingesting or feeding that data, so to hydrate your data lake, right? Now, for the data ingestion section, that shows the services used to receive your data. So either via a scalable, durable, real-time streaming service like Kinesis, or S3 as your target for batching your files. For folks unfamiliar with S3, that's your simple storage service. It's your cloud storage location to reliably and securely store your data in AWS Cloud. Okay. Now, those services are all used to hydrate or feed your data lake, and that ultimately feed that serving layer that you see on the right hand, more to the right of that diagram. So depending on your needs, right? Maybe you have low latency applications, then they require, they have low latency application requirements, excuse me, and you can leverage an operational database to kind of gain access to that data. On AWS, as you may already know, it does support relational databases as well as non-relational databases. So based on the needs of your application, that's how you can architect your solution. Now, if you need to provide a custom application with real-time access to machine learning models, then leverage maybe something like SageMaker to integrate with your custom application. Now, let's say you just need to access a metadata store, right? That's where something like AWS Glue comes in. And that allows you to leverage services like AWS Athena, right, for querying using simple SQL query codes. Maybe you have a BI tool, QuickSight, something that we have on AWS, but you can still integrate that with your Tableaus, your Power BIs, and so on and so forth. It's flexible in that state. And of course, your custom applications, you can integrate that as well. Now, the reference architecture here is an example of what you can do with this solution, or with a well-architected solution. And it does drive me to my first best practice. Now, I will say there is an application somewhere, or a data center, or a cloud environment that is not well documented, okay? So have you ever experienced trying to bring someone up to speed when you have little to no documentation on the end-to-end solution? I will tell you that I have. So our recommendation is to document everything. That may seem obvious, but so many don't do it, so I'm gonna highlight it one more time. Document everything, your business processes, your application architecture, your network architecture. If you have a hybrid environment where you've connected your on-premises location to AWS or a cloud provider, document that too. The goal is to make sure that it's easy to troubleshoot when that time comes and you need to figure out where certain pain points or what's the root cause of an issue when you're trying to deliver data from one platform to the next, right? I'll also highlight your documentation is a great way to see where your security flaws or opportunities to improve your security posture might exist, right? In addition, maybe resiliency. Right? You'll be able to visualize and see, do you have resiliency in place so that you can support any operational event that could happen in your environment. Documentation is the way. Fair.
So the following best practices are really categorized by these 4 pillars, which we call our pillars for success. The first pillar that we're going to talk about is secure delivery of data across our hybrid estate and support for flexible ingestion. And when we talk about flexible ingestion, we really mean support for structured and that unstructured data in an agnostic manner to hydrate our lakehouse. Secondly, we want to ensure that we are deploying a strong governance model that will help you maintain security and data integrity while providing self-service to your consumers. Third, very important for us in public sector, we need to establish but also maintain compliance for those sensitive data sets. And then finally, we need to protect those same sensitive data sets while also being able to share that out with our consumers in a secure manner.
Now, our goal, as we mentioned earlier, is going to be to highlight features of Databricks and of AWS as the infrastructure that's going to host your workload. So let's go ahead and see how we can accomplish these pillars. Okay, so we're going to start off with secure delivery and flexible ingestion. So I'll highlight here that when data moves, we recommend it travel over a private or encrypted channel, right? So secure data movement between your network and the cloud, in my opinion, is a key priority. So where possible, avoid the use of public internet when you can, right? So when needed, data can be sent to AWS over a direct connection, which links your network to the AWS backbone. And if you do not need, or rather if you do need to use the public internet, then what we recommend is that you at least use an encrypted channel by way of a site-to-site VPN, right? Now, if the data already resides in AWS, and it must be delivered to another AWS account or another VPC. If you're unfamiliar with a VPC, that means virtual private cloud in AWS. That's where you launch your services. Fair? So if you are going to send data between those accounts or between VPCs, we recommend that you leverage a private connection called AWS Private Link. Now, what AWS Private Link provides is connectivity between those VPCs, those AWS accounts, and or even your on-premises networks without exposing your traffic to the public internet. And that's our goal there. So when data arrives in your cloud storage, AKA S3, right, we recommend that you encrypt that data at rest. That's something that can be applied via a permission, or rather an option in the AWS console. So as simple as enabling it, everything that lands in your S3 bucket is encrypted. Okay? So this solution is meant to be flexible in that it's agnostic to the data type that you have. So you can send your structured or your unstructured data, we can handle it, and that's all supported in this flow. It's really to help increase or allow more folks to partake in or rather to add data into your data lake. Now, at AWS, we consider security to be a top priority. And by that, we recommend, in that attempt, or rather with that, we recommend that you inspect your traffic or any traffic that's coming into your AWS environment, or even on-prem, but for now we're focused on the AWS environment. So there is a cloud native firewall called AWS Network Firewall, but you can easily just start leveraging any on-premises, or rather tools that you're familiar with today. So you can always run those appliances in the cloud, and effectively you can leverage our AWS partner network to very easily or simply deploy with the push of a button. And you can probably get those tools in AWS Marketplace to simplify the deployment process.
So now we're going to focus on how to create that governance model to provide unified data access and security. So First thing we're going to really drill into is data residency. And what is that? What do we mean when we talk about data residency? Essentially, at the simplest level, it refers to the physical or geographical location of an organization's data. But what we've seen is that many organizations have data residency regulations from their government. And we're going to talk about how we can help them achieve compliance.
Thank you. So, many of you may not, if you are or aren't familiar, I'll just say this. AWS does have a global footprint, and a question that I get very frequently is how do I ensure that any of the data that you do have complies with your data residency standards, right? So with that, AWS empowers your users, or rather empowers our users or customers to be able to control in what region the data can be uploaded in or is placed, what access you have to that data, and AWS does not move your data from that bucket to replicate it in other regions. That is something that you control and you can set up as needed. So what I'd like to highlight here is if you have disaster recovery requirements, at AWS when we think of disaster recovery, we talk about or we think about regional redundancy. You can control what region you want to use as your disaster recovery region to either store that data, and you can set up mechanisms to automatically replicate that data. And that's how we apply or allow you to enable business continuity by way of your disaster recovery requirements, regional redundancy.
And for Databricks, when we think about DR, we recommend creating deep clones of your Delta tables in geo-redundant storage across AWS regions. And that's going to allow us to maintain data integrity and usability for your comprehensive DR strategy. So now that we've talked about data residency, we need to look at how we can ensure that those data sets maintain integrity. And when we talk about data integrity, it really just means ensuring that those data sets are accurate, the calculations are accurate, and your data is clean and not dirty, right? We want to allow that to be the single source of truth. So in order to do that, the first thing we're going to recommend is empower your data stewards. And data stewards at the fundamental level are folks who know those data sets inside and out. They work with it day in and day out. They understand the business context, if that data is sensitive or not, who should have access to it, the velocity in which it comes in. So it's very important to have a good relationship with your data stewards. They are going to be your best friend. And then once we actually obtain those security and standard data quality standards from our data stewards, we want to actually enforce those data quality standards and automate what we can as administrators. So one tool that we have available in the Databricks platform is called Delta Live Tables. And as you can see in the top right corner of their screen, that is an example where we're declaring that pipeline. So we're creating a live table. We are specifying the constraints on that and the expectations. So example, the year should be greater than 1900. If it's earlier than that, clearly is something wrong. And then in that same code block, we're also going to specify the action that needs to be taken. And that could be we're going to drop that row, don't really need it. We're going to continue without taking action. We're going to halt the entire pipeline because clearly this entire data set that we're receiving is wrong, or we can quarantine that record and go back and fix it later. But we're also going to be able to provide with that feature a UI where you can track those metrics as well and query that, giving you that overhead view on data quality. So as a best practice, work with your data stewards to understand that business context of your data and align with them to really get to that sweet spot of permissioning where it's not overly or under permissive. And now that we've talked about kind of how to get that information and data quality standards, we're going to talk about maintaining quality data sets in a well-architected implementation of a Lakehouse platform in AWS. So what we can see happening here in this architecture is we're first determining if this should be a continuous or scheduled data ingestion, because not all data sets have the same velocity and they shouldn't be forced to. So we're going to ingest and land that in our bronze zone. And when we think about our medallion architecture, the bronze zone is really where your raw data is landing. And it's very important to maintain the same copy of raw data. So if anything, you can always go back and access it, especially if that schema changes or you want to go back and reference that. And then we're going to move from that bronze zone to our silver zone, where in the silver zone, we consider those to be our clean, filtered, enriched data sets, where you're storing reference tables, you're starting to allow your analyst in to access that. It really should be your single source of truth. But in order to get there, we want to ensure we have those data quality checks in place. And then moving from our silver to our gold zone is where we're going to store those business level aggregates for analytics, but also our feature store for our ingestion into machine learning models. So with that, we're going to continue doing those transformations and creating those aggregates, but we'll also ensure that we have those data quality checks in place, and this is all automated, so we're not up at night receiving a call at 12 a.m. that the data's not right. And going through this process, then we'll be able to feed those consumption models for analytics, business insights, machine learning, and also our operational applications. And this is all powered on top of Spark, Delta Lake, and Unity Catalog. And what we also can take advantage of for Delta Live tables here is our continuous batch or stream processing, automatic error handling and recovery, data pipeline observability, so being able to see that full end-to-end pipeline and how those Delta Lake tables were created, automatic deployments, and also the ability to orchestrate our data pipelines. And there's also a few AWS services that are going to help out with this use case as well.
Yes. So I will not go through every one of them, but if you do want to hear about something that I don't talk about, you can always ping me outside. First one, let's look a little let's look under the hood to see what's driving some of this. I always like to call out AWS Identity and Access Manager first, because that is what's going to manage your users, your groups, who has access to what. That's all going to be included, or rather used, in order to control your access into the environment. Now, I'd like to highlight also CloudTrail. So if you want to monitor every API call that's made between services, whether it be by a user or a resource, a service, doesn't matter who makes it, any of those API calls made against any AWS service, even clicks in the console, that's all captured and logged through CloudTrail. Now, if you need environmental information, what's the state of all of my services and how can I actually gain insights into my health? That's where CloudWatch comes in. Right? That's what you will use to alarm you on whether or not there is a service that's that's not configured correctly, or that's not operating the way it's expected. That's what CloudWatch is going to do for you. I'm going to have a section where I talk a little more about a service called AWS Config, so I'm going to ignore it for now. But let's forward over to the key management service. I mentioned,
sorry, continue.
That's okay. The key management service. Now that key management service, I think I mentioned a little bit earlier that we do want to encrypt our data that sits at rest. Well, that's one place that you can store those keys, right? You can either upload your own keys or use an AWS managed key. The intention, though, is to encrypt your data, because we encrypt everything if we can, right? She mentioned about a pipeline that can be monitored and you can gain observability into. AWS Code Pipeline is one of the services that's being used to drive that piece under the hood. And it's not highlighted here, but I still want to call out AWS Private Link, because again, as data moves through your network, between accounts, between VPCs, whatever the case may be, make sure it's not using the public internet, because you don't have to. You can leverage AWS Private Link for that.
So now that we've established how to create and maintain our quality data sets for consumption, we need to understand how we can manage access to that and control it. So what we want to accomplish here is work with our business leaders to identify those data access requirements for members as our teams grow, namely going back to our data stewards who we're now best friends with. And we want to avoid overly permissive access. So here we need to remember to be intentional by applying the principle of least privilege. We also want to avoid users reworking transformations and duplicating data, maybe due to lack of discovery, and thus removing that single source of truth. And then finally, we want to ensure that we are securing that data while also providing self-service. So in order to accomplish this, the first thing we need to do is authenticate our users in groups by syncing them to AWS IAM. Then we want to leverage those IAM groups and Unity Catalog to authorize access to Delta Lake tables. And as you'll see in the bottom right corner, there is an example where we're actually choosing that privilege. We are choosing that Delta Lake table, which is a collection of files in S3, and then we're specifying the groups from AWS IAM.
Now, she highlighted two things. One, principle of least privilege. And when we say that, we mean making sure that folks only have access to the data sets that they need to use to do their jobs, meaning do not be overly permissive, as she mentioned. Right? And something else I'd like to highlight is many of our state and local government or public sector customers, they have their own solution, IDP that you're using today, identity provider that you're using to authenticate your users. That does, or rather AWS Identity and Access Management does support federated access to any of your SAML 2.0 or existing IDP providers. I think that's worth highlighting because you probably do want to leverage that and sync that with IAM to determine what permissions you give any of these users or groups or roles. And all this is showing here is that we've limited access to, in the middle, we've got clusters, right? And we've got two AWS buckets, S3 buckets, right? That's what we call them, to store your data. So you're showing, you know, we only have access to those who need it. Cluster B doesn't need access to bucket A, so it doesn't have it. And thus the users that have access to cluster B also don't have access to that data. So all we're highlighting here is just be intentional with your permissions when you're providing access to data, applications, servers, so on. That's right, keep it out. Very good. So here I wanted to highlight a couple things, right? So one, rotate your keys frequently if you can. You don't have to manage that on your own. There are services to help you manage it as well. But the key point here that I wanted to highlight is do not, if you can, help it, store your private keys, your passwords, and so on and so forth in code. I have worked with a customer where someone accidentally uploaded their code base, yes, their GitHub repository, into a public repo, and all that code was there. My point is, if the access keys, if the passwords, and all that is in there with it, you've just compromised all that. So if you're interested in not storing your keys in code, there's a solution for that as well, a service for that, an app for that. There's a joke in there somewhere. But AWS Secrets Manager, right? You can use that to store something like database credentials. That way you could make an API call to pull those credentials when you need to authenticate to the database. That's an option. Controlling access to services. We're probably going to say this quite a bit, so I'm going to say it one more time. Control your access. Instead of using users, or rather giving users access to data, you can give your applications or your servers access to data. So that term, instance profile, that's a term in AWS where we assign a instance, or let's take a step back. For those who don't use AWS, you might not know what an EC2 is. I'm just going to say a virtual machine, right? That's what an EC2 instance is. It's running a virtual machine with whatever operating system and code you want to run on it. So instead of giving a user access to querying something on your app, just give it an instance profile, meaning assign an instance profile to your EC2 instance, and then you can tell through AWS Identity and Access Manager, or IAM, what services and what parts of your data that application that's running on your EC2 instance should be able to access. Again, prioritize using instance profiles, not giving access to actual users, right, to use different services and parts for your application. Also, for encryption everywhere, I can't say that enough. Encrypt everything. Server-side, encryption in transit, encryption on server-side. You could bring your own keys if that's something that you want to do as well. Again, you can manage them on the key management service. I've mentioned that before, so I won't highlight it too much again. But encrypt everything and encrypt every connection. I will highlight 2 points that folks are usually interested in. One, when it comes to the server-side encryption, AWS uses AES 256-bit encryption to encrypt on server-side. And for your TLS encryption, for any encryption in transit, 1.2 or higher. So that's already supported. Just leverage it, right? Access control list. Probably won't be the last time I mention that today, or first or last, but I will say you can leverage NACL's Network Access Control List in AWS to define what CIDR range has access to certain parts of your environment. For those who aren't familiar with, CIDR range could be, you can either add one IP or a range of IP addresses that will have access to leveraging or accessing resources in your AWS environment, or in your VPC.
All right, so now we're going to move to maintaining compliance. So Databricks handles the most sensitive data in the world, and we have a strong security program that's backed by compliance and security standards. We have an aggressive compliance program with rigorous third-party audits performed at least annually. We also have an enterprise-grade security program that covers application security, infrastructure, and security operations. So in addition to AWS GovCloud, you can see all of our certifications and standards we comply with here.
Very good. And she mentioned GovCloud. I'd like to highlight something about that. Because if you're a government organization, that doesn't mean you need to move your workloads into GovCloud. I like to think of it as a compliance cloud. So if you have compliant workloads that, that require ITAR or CGIS or something like that, some level of compliance like that, that's where you would that's what would drive your decision to moving your workload into GovCloud. Not just because you're a government organization, just something to think about. Now, I talked about a service called AWS Config a moment ago, or at least I mentioned the name. And that is a service that allows you or enables you to assess, to audit, and evaluate the configurations of all your AWS resources. I like to highlight a good example, which is maybe you work with central IT, and you want to make sure that every agency or every department complies with your standards. Always use HTTPS. Never have port 22 open to the public internet, things like that. You can apply or create those rules in AWS Config. It'll monitor your environment. And let's say you started out that way, meaning you've developed deployed an environment for folks to use, but then someone logs in and starts changing settings. This is the service that will actually alert you to those changes. It's also the service that will automatically try to remediate that issue as well. It's on you if you choose to do so manually or automatically, but it's an option. The other thing I would highlight here is conformance packs. Right? Maybe you're unfamiliar with them, but I want to highlight what it is. A config conformance pack is a collection of rules that AWS put together that might help you achieve some compliance standard. Let's use HIPAA as an example. Instead of you reading through the documentation to see exactly what's required to be compliant with HIPAA, instead, you download the conformance pack, right? And you upload that. And now all of those compliance requirements have been set in your environment, and those rules are now configured, and it's monitoring to see, are you in compliance with HIPAA? So something to look out for. That way you're not having to write those rules on your own. There's services to help simplify that.
So just to quickly go through some best practices to manage access to PII, we're not going to go through all of these. We're just going to cover a couple. You'll have access to these slides and the video recording later, but just a couple to highlight here is use transaction logs for auditing, leverage table ACLs when you can, and configure dynamic views for redaction of sensitive data. And that can enable row level, column level, and attribute-based security. And now that we've reviewed some of those best practices for securing our sensitive data, we're going to look at some other best practices for protecting our data and sharing it out.
All right. So this might be a little bit of a repeat, but I wanted to hammer this home. 1, bucket policies. Every S3 bucket that you have holding all your data, you can assign policies to say what IP addresses, what users, what services have access to that data. Keep that in mind and scope it down to only those who need it. NACLs, or Network Access Control Lists. Define who can access your network. That gives you protection from your VPC right at the network layer, right? If you're not allowed, boom, we don't even give you a chance to access those servers. We can protect you starting from there. Security groups, this is almost going to be like a essay associate exam if you're interested in taking that exam next. But security groups, that protects their instance. So the instance that's running your data, you can define what ports are going to be open for them to access that virtual machine. And also you can say what IP addresses have access to using those ports, things like that. That's where you can protect the instance that hosts your application, right? Private or protected communication. That's just an oversimplification of choose private communication methods when you can. If you need the direct connection, that should be the option if that makes sense for your organization, or leverage a VPN. And when I say protected communication, if you have a use case where the data must be available on the public internet, can I recommend that you at least put a password authenticator in front of it? That's essentially, try your best to add additional locks to that data if you can. The last two that I'll highlight here are two services from AWS that help with cybersecurity, especially with automatically identifying anomalies in your network or in your environment, we'll say that. So AWS Guard Duty. If you're looking for a threat detection service that continuously monitors your AWS accounts, all those workloads, all that, for malicious activity, that's the service for you. It delivers detailed security findings for visibility and remediation. This next one I think is a little less known. It's Macy, right? So if you need a managed data security and data privacy solution that uses machine learning and pattern matching to discover and protect your sensitive data. If you have data in an S3 bucket and you want to make sure you're not accidentally putting personally identifiable information in there, this is the service that will alert you if it finds social security numbers or things like that, those PII data. This is the service that will identify and alert you immediately, especially if you have public buckets. Would I recommend that you at least look into something like this?
And just to quickly wrap up, now that we know how to protect our data on AWS, we're going to talk about a few methods to securely share that out via Databricks. So first, for your data scientists and engineers, notebooks within the platform where they can access the raw data in S3 or those Delta tables for our bronze, silver, and gold layers. Secondly, for your developers or who are more comfortable working in IDEs, a secure ODBC or JDBC connection. Now, if we look at access for our analysts who are looking at those silver and gold layer tables, Databricks SQL endpoints where they can connect from their BI tool or leverage a tab SQL editor. And then finally, if you have a consumer who's not in AWS, they're not in Databricks, have no fear, because we do have open source Delta sharing where you can share that out with those consumers and it pushes the data from your AWS cloud account.
Very good.
So thanks for joining us today. It was wonderful to speak with y'all. We hope to iterate on these best practices, and we're happy to be here.
Yeah. And so if you're interested in staying connected, please find us on social media. I'm happy to have this conversation. And one last thing I'd call out, AWS is offering $50 in free credit. You're welcome to go ahead and scan that code, because you can actually gain training material, as well as if you are kicking off a free trial, we'll throw in $50 worth of of no-cost credits to your solution. So please, if you want to take a time, access that.
Awesome. Thank you both. I know we don't have time for questions, but you can find the speakers down there. And one last thing before you leave, please fill the feedback survey on your mobile app for this session. So it will greatly help us improve the sessions as we go forward. Thank you so much.